Hello, Sam Moser here. Welcome to the back of my van. So if you've seen the tour video of my van, we're basically underneath the bed which goes across the back. And back here is where a lot of the systems are. So the water system and the water tank is all housed over here, and then the electrical system over here. And the last few videos I've done have been about the electrical system. The last two are on batteries, and this one's kind of going to be the final wrap up of those videos on the electrical system. So what I'm going to do is a walkthrough of the full electrical system diagram, and then we'll go over some notes about the installation of it. And I'm not the biggest fan of how my wiring install actually turned out. It's a bit messy, and I'd like to redo that in the future, but functionality wise, it's worked out perfect. Alright, let's get into it. So let's go over this. The full system diagram showing all the components and how it's all wired together. I'll share my screen with you here. So this is the overall system diagram, and in the video description below, I'll put a link to a web page you can view this at. I've split this up so that on the left here, we have all the charge sources: solar, alternator, and the AC charger. These are the same ones I talked about in my first video on the electrical system, but here we'll go into all the details of exactly how they're wired up. In the middle here, we have the storage and distribution. So this is essentially the battery and the bus bars that then spread the power wherever it needs to go or receive the power. And then on the right, we have the consumers. So the DC loads, all the DC circuits will hook up, and the AC loads. Let's start by talking about the battery, or the storage and distribution. So in the center here at the bottom, we have the battery. And right on the positive terminal, we have a fuse. So this fuse will protect the battery in case of catastrophic failure, really. It's the biggest fuse of the system, and things would have to go majorly wrong for it to blow, but there for safety. Everything else that connects to the positive terminal of the battery connects past this fuse. And the way this fuse holder works is you essentially have a new screw terminal on the top of it. Right past the fuse, we have a system switch, an overall cutoff for the battery. This is really important for when you're installing the system or any other time you're working on it, that you can flip the switch and cut off power from the battery entirely. Past this, this goes up to the positive bus bar on this hub here, which we'll get to in a second. Let's go back to the negative terminal of the battery. So on the negative terminal of the battery, before it goes up to a negative bus bar, it runs through a shunt here for the battery monitor. In my case, I used the Victron Energy BMV712 smart battery monitor. And this one's nice. You can connect to it from your phone to view the state of the battery. It shows you, the voltage, the current going in and out of the battery at any time, what the state of charge is, how many amp hours have been consumed since it was last at a full charge, and some other useful stats on the battery. I like this battery monitor and find it really useful to have. You don't necessarily need one this fancy though. At a minimum, you want to be able to know how charged your battery is, and the state of charge is directly related to the voltage of the battery. So a very simple, minimal setup would just be some sort of voltage monitor on the battery. Now, the shunt here connects to the negative terminal, and it connects inline, which allows the battery monitor to read the current. Then there's a connection from here to the positive terminal of the battery, and that lets the battery monitor see the voltage of the battery. And with the combination of the voltage and current, it calculates everything else from there. In order for the battery monitor to accurately monitor the system, it's important that nothing is connected on this side of the shunt. So you run the other side here up to a negative bus bar, and you want all the other negative connections in the system connected to the negative bus bar here and not directly to the battery terminal here. Okay, so moving up the chart from here, we have this component, which is the Blue Sea Safety Hub 150. And this thing basically combines a negative bus bar, a positive bus bar, and a number of fuse holders. Alternatively, what you might see is just two separate bus bars, and I drew an alternate version of the diagram that shows that. So in this case, instead of having that hub, you have a separate negative bus bar and a positive bus bar that all your negative and positive connections then tie into. Either way works. You'll find that on a lot of the items going into that positive bus bar, they need their own fuse or breaker. And you could do separate breakers like I showed here. I found that it was a little easier and required a few less components to use this safety hub instead. You are limited on the number of large fuses it can hold though, for here. So depending on your system, this might not work for you and you might want to go with the dedicated bus bars. I found this safety hub to work nicely though. So rather than talk about each of these connections going in, let's zoom back out and we'll go through the charge sources first. So starting with solar here, we have our panels. In my case, I used 3 100-watt panels, and all those are connected in series. I talked about that in the first video on the charge sources, so I won't talk about that more here. All the connections in between the panels and from the panels to the wires that then go inside the van are made with this connector here, which is called an MC4 connector. MC4 connectors are pretty standard for solar panels. The panels are usually sold with these already on the ends of the wires. They're a really good weatherproof connector, and since these connections between the panels are sitting on the exterior of the van up on the roof, it's important that these are connected in a really weatherproof way. You usually don't have these hardwired together either, because if you're ever changing up your panels or doing other maintenance, you probably want a way to easily disconnect these. So generally, I'd say stick with the MC4 connector here. Then, where the cables pass into the van from the outside, you'll usually see something like this. So this is called a cable entry gland. And I'll put a link to all the items on this diagram in the video description. The way this entry gland works is you cut a hole in the roof for the cables to pass through. Then you mount this entry gland over those holes, feeding the wires through. It all seals down and you use sealant all around the edges. The wires pass in and out of these little knobs here, which those tighten down and really cinch down around the wire and make a tight weatherproof connection. So past this, the negative connection here from our solar panels goes directly into the negative solar panel connection on the charge controller. The positive, though, first goes through a fuse and then a switch. The fuse here is going to protect your wiring as well as your charge controller in the case of some sort of failure from the solar panels. And the switch allows you to cut off this charge source should you ever need to, really only if you're doing something to the panels. Other than that, I pretty much always just leave this switch in the on position. So as far as connections to the charge controller here, we have the solar panel or photovoltaic PV plus minus, and then the battery positive and negative. And then each of these is running to those positive and negative bus bars on that hub. Moving down from the solar, we have the alternator charger. And I'm going to turn off this layer for now. So we say alternator charger, but really we're connected to the starter battery, not the alternator itself. In the Transit and some of the other cargo vans, the starter battery is underneath the passenger seat, and that actually makes this easier to connect to because you don't have to pass anything all the way through to the engine bay. The positive connection here from the starter battery goes through a fuse and then a switch and then to the battery-to-battery charger. So fuse and switch, same ones used for the solar panels. Fuse size is a little different though. The other connections on the battery-to-battery charger are a ground and the output from the charger. Per the instructions from Sterling, who makes this battery-to-battery charger, you want the starter battery and your van's house battery here to have a direct ground connection. And I used a pretty heavy gauge wire for this, and this is how my whole system is grounded to the vehicle's ground, is through this connection here. So this runs from the starter battery's negative right into my negative bus bar. Okay, so moving down from the alternator, we have the AC charger or shore power charger. And in my system, I don't use this one much, so I went with a pretty small charger. This is the Noco Genius, and it's only a 10 amp charger. It basically plugs into just a normal electrical outlet, and the cord on it's pretty short, so I normally carry an extension cord so I can run this into an outlet a little further away from the van. The connections on this are pretty simple. It's got that AC input, and then it's got a positive and negative output that you run to the positive and negative bus bars. It came with an inline fuse holder here, and so I kept that 15 amp fuse in it. Now, I wanted to be able to use this charger to not only charge the house battery over here in this system, but to also charge the van's starter battery. What I actually did was I added a switch. This is a two-way switch where it'll only connect to either one side or the other at once. And on one side of the switch, we go to the positive bus bar for our system here. On the other side, though, we essentially go to the positive of the starter battery. I still connected to this side of the fuse here, although since there's another inline fuse here, you really could connect this directly to the battery as well. This was just the closer connection to reach. One important thing to note here is that if you do have this switch turned on to the first position where it's going to the starter battery here, you don't want to have the battery-to-battery charger on at the same time. You'd want this one off. And in my case, I don't use the alternator charger as a main charge source. I keep this one off the majority of the time, other than when we're going through those stretches where we haven't had enough sun to keep the battery charged just by the solar. So if you do leave this switch on all the time, you want to make sure that if you ever switch this one on to charge the starter battery from this AC charger, that you switch off the switch here for the battery-to-battery charger. So that's really about it for how these three charge sources are hooked up. Each of them then goes into these connections on the safety hub, where it then goes through a fuse before coming to the positive bus bar. So let's move over to the other side of the system. So these are the two basically groups of consumers, our DC loads and our AC loads. So the DC loads are going to be all the components and appliances around the van that can run directly on that 12 volts DC power from the battery. So in my case, this was the lights in the ceiling, the roof vent fan, the fridge, the 12 volt and USB charge ports around the van, and a few other things. So really you want to try to power as much as you can directly from that 12 volts DC, because it's going to be more efficient than having to go through an inverter and create AC power. For anything that you can't power directly from 12 volts and that needs a standard 120 volt AC connection, you need an inverter. And that's what I have here marked for AC loads. In our case, there weren't very many things that we wanted to power that needed 120 volts AC. It was really only our laptop chargers and occasionally a small blender we would use and make smoothies or something. Now, the inverter itself was located down under the bed, so it was hard to reach these plugs right on the inverter. So I found this extension cord that then has a inset, a little receptacle here that I mounted in the wall. And this gave me a way to have, two 110 volt AC outlets towards the front of the van. This inverter in particular already has a GFCI built in, but if your inverter doesn't have a GFCI, then you'll want to make sure that the receptacles you wire to it include that GFCI. The inverter itself just connects right into those positive and negative bus bars, and this is going to be high current. If we're talking 1,000 watts here at 12 volts, that's over 80 amps of current, and this thing can handle up to 2,000 watts of surge power, so that's going to be close to 160 amps of current. So the cabling going between your inverter and your bus bars should be pretty heavy duty. In my case, this inverter included cables, so I used those provided. I thought they actually seemed a little on the small side based on how I sized all the other wirings, but since they're the ones Energy provided, I trust them and went with those. Now you might see some inverters that will have instructions that tell you to connect them directly to the battery. If you're using a battery monitor such as this, you don't want to do that. You want the battery monitor to also be able to monitor power coming in and out when the inverter is being used. And so you still want to have this connected to your positive and negative bus bars. You just want to make sure that those bus bars you're connecting it to and the cable going between your battery and your bus bars can handle the high current that the inverter is going to draw. So in this diagram, I also marked what was the gauge of cable I used everywhere. If you look between the bus bars and the battery here, this is 2/0 cable. So that's pretty heavy duty stuff. A note here, everywhere else on this chart, I marked the wire gauge that I used for those connections. And I was going to do a video where I explained how to come up with the fuse and wire gauge size, but there's actually a chart from Blue Sea that I think does a great job walking you through how to calculate those. So I'll link to that chart in the video description. Another thing to note in terms of the wire gauge sizing is I tried to use the same wire gauge in as many places as possible to keep things simpler, especially when it came to ordering the wire. And basically what that means is you might end up having to use a heavier gauge wire in some places than is actually required, but I think that's worth it if it simplifies the number of different wire gauges you have to buy. Okay, let's go back over here to the DC fuse box. So I kind of skipped over this one before, but connections to it are pretty simple. There's a positive connection from the positive bus bar, a negative connection from the negative bus bar. This then is where all of your circuits that are going around the van to those different items are connecting to. Now, one thing you'll notice is that the positive connection going to our DC fuse box here also goes through a fuse before connecting to the bus bar. And it might seem redundant to have a fuse here when every connection coming off of this DC fuse box is fused. But really, what this fuse is doing is it's protecting the cabling going to that fuse box itself. Now, fuses protect the appliances connected to them, but more importantly, they protect the cabling. And the reason the cabling needs to be protected is because if there's a short or some sort of failure where more current gets drawn through those cables than is supposed to, they're going to heat up and they could eventually melt or catch other things on fire. Now, by having a properly sized fuse or breaker on all these connections, that fuse or breaker is going to blow before that wire can get so hot that it melts or catches anything on fire. So fuses are of extreme importance. Make sure you're picking your wire size to handle the appropriate amount of current it'll see, and then make sure you're choosing a fuse size that's going to protect that cabling. Okay, so I think that basically does it in terms of going through this diagram. Now let's talk about a few things in terms of the install of all this. The first thing I did was build a platform over the wheel well where I wanted my battery to sit. Next, I put up this board which I'd be mounting most of the major components to. Before this though, I had brought this board inside and figured out where to locate everything on the board, then traced this out and started prepping the cabling. Once it was back in the van, I mounted everything to the board and made all the connections. On the left, you can see my bundle of wires coming down from the ceiling. I used marine grade duplex wiring. This wire has a really thick protective sheathing, and duplex means that there are actually two separate strands of wire inside, one for positive and one for the negative connections. This wire is stranded, not solid core, and suitable for use in environments where the wires are going to see lots of motion and vibration. I used these splices where I needed a parallel connection, such as for the lights. I used quick disconnect connectors wherever the wires connected to a component. A crimping tool is used to attach these to the wires, and they come wrapped in shrink wrap. I used split loom tubing in areas where I wanted to protect the cables from sharp edges. I also used a lot of zip ties to hold everything in place. And that's about it. I hope you found this video useful. Subscribe for more build videos. See you next time. Bye.